Now, viewers, you are welcome to continuation of our discussions on countable spaces. Today we are going to take the first countable space. Now, one good thing about countability axiom of countability is that it allows us to study the complex topological structures by mimicking the topologies as sequences of of open sets, sometimes nested intervals, sometimes ordinary just open sets, so that we can now treat those complex structures of topology using these sequences. We will now study the closure, the compactness, and so on, using maybe convergence and so on and so forth. So this is one of the importance of the countability axiom. Now it is first countable space. We start with definition. A topological space X tau is called first countable. Okay, it is a topological space is called first countable, or is said to satisfy first axiom of countability if for any point you pick in X, the space, okay, there will exist some beta I, okay, let me call them beta I, which are where the beta I are nested, we call them nested sequence of open bonds. Okay. Okay. Cos in X. Okay. So the beta i's are all actually contained in X itself, such that every neighborhood of this you pick, if you make some neighborhood of X, that neighborhood will be contained in some beta I or some I, okay? Of course, you require I to be so that the sequence is also countable. So we index the I and N, making the nested intervals countable, okay? So every neighborhood you pick of this point X is going to be contained. So you are imagining a situation where, for example, maybe that if you take R, okay, or Rn, whatever. So maybe this is your X, okay? But meanwhile, you are going to have some nested intervals like this, okay? So these are your beta I's. So every neighborhood you pick of this X here, this is your point X, then every neighborhood will be contained, that neighborhood is contained. So because this is beta 1, beta 2, beta 3, beta 4, so that you can see clearly that this neighborhood is contained. Neighborhood of X is even contained in beta 1. Okay, so that means this is now one of the examples is if you want us to give examples, I say a good example is the metric space. Metric space topology is a good example of first countable space. Okay, for example, if you now index your nested to be set of X and maybe 1 over N was the radius. So these are your beta. We call them beta N. So these are your nested interval with this radius. You find out that for any point X, if you pick now, for example, you have a line, the metric, so that means the distance, supposing this is your X, okay? Meanwhile, you have this radius, you have this beta i's, these are your beta i's. Then any neighborhood you pick around X will be contained in one of the balls. You can see every neighborhood of X is contained in some beta I here. So that metric space, that topology which is endowed with the metric as distance function, is a good example of a fast countable space. So welcome to next presentation.